All right, good morning, everybody. We need to talk about adding and subtracting rational expressions. Basically, it's adding and subtracting fractions where we have complicated fractions. We want to keep things in common, or we want oh my gosh, I'm trying to read and talk at the same time. We want to keep things in mind. We need to mainly focus on common denominators. Okay, I just did this example in class, but what we're talking about here, 2/3 plus 1/6 of a pizza is really hard to do. So what we need to do is we need to kind of swell up the denominators and multiply these so that the denominators become the same. Then we'll have basically 4/6 plus 1/6. And when we do that, that is going to equal to 5/6. And we're going to do the same exact process today. Number one thing we're focused on, common denominators, okay? They're not common, so we had to make them common using multiplication. And then this is also important. Combine the numerators, keep the denominator, okay? Look, it's the same thing we did here. Add the tops, leave the bottoms alone. Lastly, simplify, right? This is really the stuff that we've been working on this week of crossing stuff out. So let's look at these questions. Get the common denominator and then do the addition properly. Not too bad. Number one, we need common denominators. Do we have common denominators? Yes, we do. Beautiful. Okay, that means we are ready to add these up. Okay, we need to just leave the bottom alone and we need to add the tops together. 13a plus 5a is 18a. That's adding fractions with common denominator. It's a piece of cake. Now we need to simplify this, and we've got, now our new rules, just like we talked about yesterday. None of this stuff is locked together. We don't have any pluses, and so we can kind of hunt around and find anything that's common. I'm noticing that the 18 and the 4 can both be divided by 2, so that's going to leave me with a 9 left over and a 2 left over. Right? Basically, 18 is 9 times 2, and 4 is 2 times 2, and we've crossed out the 2 on the top and the 2 on the bottom. Now I've got a and I've got a squared. A squared is basically just AA, and so I can cross out one of the A's and one of the A's, and I'll have one A left over in the denominator. So to kind of clean this up, I've got only a 9 in the top, I've got a 2 and an A in the denominator, and we're done. So importantly, these denominators are allowed to change once we have already combined it into one fraction. Then we're allowed to simplify them. But in this combination step right here, leave the bottoms alone. Okay, moving on, going quickly. You guys are killing it this year. Do we have common denominators? Yes. Perfect. Okay, excellent. So let's just do the subtraction. Leave the bottoms alone, and now it's time to do the subtraction. Now, I want to remind you guys back in the day where we were doing questions like this. Okay, and I told you, hey, be careful of this question. It's not hard, but everybody's going to miss it for some reason, okay? And I asked you, give it a shot, and we still had so many people miss it. And the reason is, everyone's going to do 2 minus 5 is -3, but then people are going to do 3 plus 4, and they're going to forget that we need to subtract these two things. It's not 3 plus 4, it's 3 minus 4. So it should be -1i, okay? Same exact thing is going on right here. Same exact thing is going on here. Let me get rid of all this little example problem. We need to do 9x minus 7x. Everyone's going to get that right. 2x. Oh, I accidentally got rid of my 6 here. Everyone's going to get that right. But so many people are going to put 14 right here. It's not 14. It's 12 minus 2. So it should be 10. Okay? So many people are going to make a mistake there. It's not difficult. This minus sign is going to trick some people. Okay? I like to do this kind of thing, which reminds me, subtract it. Okay? It's kind of like distributing the minus sign. It will save your life, I promise. So from here, now we've got everything combined. Now, pretend this is a question from yesterday, and this is where you started, okay? Factor if you can, cross out if you can. So I need to factor the top. I'm going to go ahead and factor the top, take out a 2, left over with x plus 5. That's a little GCF over 16. And now I'm noticing that this 2 and this 16 can be reduced because the 2 is not locked to this x plus 5, so it can be reduced. Cross out the 2, cross out the 16. I'm going to have an 8 left over in the bottom. Final answer, x plus 5 over 8. So when it comes to addition with common denominators, really pretty easy. When it comes to subtraction with common denominators, still easy, just be careful. Okay, let's look at a question like number 3. This is a lot more along the line of how a test question would look. Do we have common denominators? Yes. Time to go ahead and add them up. So leave the bottoms alone, right? Even though the bottom is a little bit more complicated than we've seen, we're still leaving the bottom alone, just like in our regular old pizza question that we did up there. Now on top, we need to add these two things together. And again, adding the tops hopefully isn't that tricky. It's a y squared plus, there's no y squareds, which is y squared. It's an 8y plus 2y. So it should be 10y. And then it's a 21. There's no other numbers, so it's just a 21. Okay, and again, have this mindset of, okay, I've combined them together. Pretend this is where you started yesterday, okay? And you'll be able to solve this question no problem. It's not a multiplication problem anymore. It's not a division problem anymore. So it's a really easy simplifying question. Factor it, cross the stuff out. So I'm going to factor the top. Again, I'm going to factor these quickly because you guys are really sharp factorers, and I don't feel like we need to spend forever doing the factoring. Plus 7 plus 3, that's going to multiply to 21. That's going to add together to make 10. On the bottom, that's difference of squares, parentheses, minus, plus, y times y, 3 times 3. And just like we expected, something's going to cancel out. Y plus 3's are gone. Leftover answer is y plus 7. And on bottom, y minus 3. Now again, this should feel really easy when you have common denominators, okay? Should feel like a walk in the park for the most part. You know, we've got some questions here. Subtraction, be careful. You know, let's set up this question. I don't know that we'll even solve it. Maybe I'll factor it for you really fast. But looking at number 5, I just want to do this because we have a subtraction question, okay? And we're ready to do the subtraction. I need to make sure I subtract the n and I subtract the 1. So, in doing that, the denominator will stay the same. The numerator needs to be subtracted. That's n squared minus, there's no other n squared, so it's just n squared. 3n minus n, it's going to be 2n. And then here's the part that people would mess up. Negative 7 minus 1. You're down 7, you go down 1 more, you should be down 8. Again, that's not really tricky compared to some of the stuff we've done this year. Just be careful. We need to go ahead and, you know, to do this question just for the sake of finishing it. I'll go really quickly. That's going to be n plus 4, n minus 2. And in the denominator, it's going to be n plus 3, n minus 2. And of course, we're going to cross out the n minus 2's. And of course, our answer is going to be everything left. N plus 4 over n plus 3. Okay, hopefully this feels like, if anything, exactly the same as what we did on Monday, right? Not nearly, you know, as challenging as far as learning new material. This probably feels like, you know, one small new piece. But unfortunately, it's not always that easy, okay? We're going to get to questions. Let's move down to question like number 9. we're going to get to questions where we have uncommon bases, okay? And so I'm looking at number 9. I see that we have 5k minus 10, and we have k minus 2, okay? And I need these to be common denominators before I can do anything. And so right now, I have a great big, kind of stop sign where I can't do anything until these two things are equal to each other. So I need to get them equal to each other, and it's not always clear what we're allowed to do to get them equal to each other. Now, to remind you guys of the question that we did earlier, the only strategy we're allowed to use to alter this fraction to make it look like this fraction is multiplication, okay? Multiply by 2. We could not add 3 to the denominator. That's not fair. So multiplying by 2 is the only thing we're allowed to do. So back here on number 9, the only thing we're allowed to do is multiply. What are we going to do to make these bottoms the same? Anybody in class have any ideas how we're going to get these two bottoms to be the same? Times by 5, where? Right. I agree with you 100%. Now, let's make that really obvious why we're going to multiply by 5. If we think about factoring the denominators, and I factor this denominator so that it has 5 times k minus 2, right? That's just me factoring the denominator. Now how you can picture it is the left side has a 5 and a k minus 2. The right side only has a k minus 2. So how do we get them the same? We just need to make sure everything has the same kind of pieces, okay? And so what I like to do a lot of times is I like to make a little, denominator list. And that's a little too long, so I don't like to write that the whole time. But I like to make a little denominator list, and then I like to list every factor that I see in the denominator. Okay, I see a 5 in the denominator. I also see a k minus 2 in the denominator. And then I see another k minus 2, and that's already in the list. So I don't need to put that in the list again. And so all of my denominators need to look like this. They need to have a 5 and a k minus 2. And so, of course, you guys are absolutely right. This one needs to be multiplied by 5. That means the top has to be multiplied by 5. And so now it's time to sort this out. My bottoms are the same, and so the bottoms should not change, right? That's the same rule as always, but it's a little bit weirder now. It's a 5 and a k minus 2. It's a 5 and a k minus 2. And so it's going to stay a 5 and a k minus 2. Now on top, this is where things get a little bit tricky, okay? We're going to be asked to do a lot of PEMDAS specific algebra in order to handle this, okay? I'm sure for this question it's pretty straightforward, right? We've got k squared plus 16. You guys can do this. 4 times 5 is 20. So it should be minus 20. Okay, and make sure that you've got this minus. Like I said, minuses are the kind of the tricky stuff that we have to handle. And from there, we're still trying to sort out this numerator. Okay, this numerator is still not as condensed as it can be. We're not even ready to factor it yet, okay? Because we could still take this 16 and this 20, and really it's a negative 20, and we could still make that smaller. So what we're going to do is we're going to go from here to k squared minus 4 over 5k minus 2. Now that we've condensed the numerator as much as possible, now we need to begin our process like yesterday. Now we need to factor it. Now we need to cross stuff out, okay? Good thing is it's a really easy one to factor. The numerator is difference of squares, a minus and a plus, k times k, 2 times 2. And on the bottom we have 5k minus 2. Of course, we're crossing out the k minus 2's, and so we have k plus 2 over 5. So this all of a sudden became quite a longer list of things we needed to do as soon as we have uncommon denominators, okay? We need to make them the same, and in order to realize that, we had to start, number one, factoring the denominator. Okay, so I'm going to make a little list over here. Step number one, we like to factor the denominator. Okay, that's going to give us a clear picture about what is in the denominator. Okay, then step number two is going to be common denominators. And our goal with this step is to kind of recognize, oh, that's not good, denominator. We need to kind of realize which of these fractions is missing something, right? This one was missing 5, so we had to use multiplication, okay? I'll put a little hint on here as well, right? Use multiplication. Maybe just use multiply because I'm running a room. And then once we've done all that, we need to kind of PEMDAS the numerator. Okay, we had to handle all of this stuff. The 4 times the 5, the 16 minus the 20, okay? We had to condense it, make that all look nicer. Of course, PEMDAS is parentheses, exponents, multiplication, division, addition, subtraction, order of operations, basically. And then step number 4, finally, we're back to what we did yesterday, right? Finally, we're back to simplify rationals. Ooh, that's not what I meant to press. Finally, we're back to simplify rationals. Okay, like I said, it's a longer list for sure. Much longer when we have uncommon denominators, and it's going to require a lot more patience and organization. Trust me, you'll see once we do a couple more questions. Okay, number 10. On the last question, it was pretty easy. Okay, I had students in class who said, you know what? Multiply by 5, right? Great job. This one, it is going to be much more difficult. Okay, are they the same? No. Which side do you think is missing something, the left or the right? Of course, the left side is missing something. Okay, what is it that you need to multiply the left by to make them both the same? And that's a really, really tough ask unless you're already able to factor the bottom in your head. So we might as well just factor it on paper. If I want to take this bottom right piece, I see that it's a y squared, so I see that we can factor it. And I want to factor it into 2 parts. Anybody know what multiplies to 24 and adds to make 11? Right. And of course, just like on Monday, we're kind of outsmarting this here and thinking probably they have the 8s in common. It's probably this one that we're missing over here, right? And so we do think like that. We get y plus 3. Now, you know, we don't really need that portion anymore. We're looking at it like this. And now I'm kind of making that list, okay? And again, on a question like this, it's not super important. In the future, it will become more important. What are some different stuff you see in the bottom? I see y plus 8s in the bottom. I see y plus 3s in the bottom. Obviously, we have 2 y plus 8s, right? But we don't need to list both of these. There's y plus 8s in the bottom. And so I'm thinking, okay, if my denominator can look like this, then it'll have all the parts, right? This one is already good. This one is missing the y plus 3. So we have to put the whole thing over here, y plus 3. That means we have to put that same thing on top as well. Y plus 3 has to go on top as well. So now, zooming in a bit. Now we can see that our denominators are the same. We have a y plus 3 and a y plus 8. We have a y plus 8 and a y plus 3. We have exactly common denominators. That's really good. We're able to go here. Y plus 8, y plus 3. Feeling good. Now the numerators, we have to sort out very carefully. And in order to do that, we need PEMDAS, we need order of operations. This piece in particular is a bit tricky, okay? It's a y plus 3 times 7. And what we need to do here is distribute the 7, okay? It probably would have been more obvious if I wrote the y plus 3 on this side, because normally we see this piece going into the right. But even though the 7's on the left, this is multiplication. Now, this is where you have to be very careful and consider, do you want to do this in your head? Or do you want to maybe have another step here where you write it down carefully, where you put y plus 3 times 7 plus 35. Or you could go straight into this step, right? You could say 7 times y is 7y. You could do 7 times 3 is 21 plus 35, right? Don't forget this part, the plus 35. So you could do either one of those steps. Now, I want to point something out, though. Some of you will go this way, which is the slower way, kind of the more safe way, which is good. We're going to need to distribute the 7, of course. But then we'll have a couple people make a mistake, okay? And they'll see, hey, wait a second. I've got the y plus 3 and the y plus 3. I can just go ahead and cancel these out. That's not true because this plus right here is locking this to this. The 35 is locked together with a plus. It's not the same. Obviously, this one right here is a multiplication bond, but this one is a plus. And so you cannot cross these two things out. I see that mistake happen a lot, okay? What I would do, we're going to need to multiply these. That's going to be 7y plus 21 plus 35. I still need to condense the top. So I'm probably writing this again. Still need to condense it. I've got 7y plus 21 plus 35 is 56. And now you might be thinking, okay, nice. We've simplified the top. We've got common denominators. But now we have to start the question like we would start it on Monday, right? Now it's time to simplify this question. 7y plus 56. Can we factor this at all? And you might be surprised at how this is going to end up happening, even after all this weird, addition and stuff that we had to do over here. That's going to factor. We can take out a 7. 56 is 7 times 8. And now, this is when you might kind of have a little surprise moment. We're actually going to be able to cancel out the 8s at this point. Well, the y plus 8s at this point. Again, really hard. You cannot predict that happening. If you remember up here, I told you that we were not allowed to cross out the 3s, right? It looked like the 3s were going to get crossed out. But once we did PEMDAS correctly on top, turns out that actually the y plus 8s are going to get canceled out. Final answer, 7 over y plus 3. All right, let's look at a question like number 14. We're going to do this really quick. I want to do 2 more questions. That's it. A question like number 14 is a question that a lot of students will get stumped by, okay? They'll see b plus 3, a regular old b, and they'll have to get common denominators. How do you do that? What do you guys think? How can we handle 14? How can we get common denominators on a question like this? What do you guys think? Well, let me offer this. What if I propose to you guys? Boom, common denominators. Is that legit? Is that allowed to happen? I mean, it looks good. Looks like we got b plus 3, b plus 3. Any concerns there? if we take a fraction, let's just take a fraction like 2/4, and we do something like this, plus 3 plus 3. Does this stay the same fraction? Is 2/4 the same fraction as 5/7? No, right? This one right here, this is 1/2. This is half a pizza, 2/4. This one right here, oh, I'm going to have to draw 1/7 of a pizza. Not bad. This one right here is 5/7. 1, 2, 3, 4, 5. Yeah, these are not the same fraction. And so adding 3 is not allowed, okay? Let me not make this so loud. We're undoing all this. Adding 3 is not good. I tried to even give you guys a little hint. If we look back on our list over here, use multiply. That's our only thing we're allowed to do to make these denominators the same. And so looking at number 14, how can we use multiplication to make them the same? And again, even smart students are going to be confused here. They'll be like, well, I guess we just have to multiply by 3, right? And if we try that, we're going to get b over b plus 3 minus 12 over 3b. Still not good. Still not the same, right? What the heck are we going to do? What do you think, Jabarius? These ones right here? These ones right here? No, so we're only able to do that if we have multiply. I see what you're saying, though. If this was multiply, we could cancel these out. But with subtraction, we have to do the subtraction, which means we have to have common denominators. Here's what we need to do. Follow the list. Step number 1, factor the denominator and then get common denominators. Okay, can we factor the denominators for number 14? No, they're already simple, right? Can't factor this, can't factor this. And so let's make a list of everything that you see in the denominator. I see a b plus 3 in the denominator, and I see a b in the denominator, right? I mean, this is basically like a b plus 0. I mean, you would never write that, but don't let these like small simpleness of the regular old b confuse you. How are we going to make common denominators here? Well, we say both pieces need to have a b plus 3 and a regular old b. So what we have to do is we have to say, okay, this needs to be multiplied by b. And we'll have to do that to the top as well. And then on the right side, we'll have to say this thing needs to be multiplied by b plus 3. Make sure that looks like I'm multiplying. This is the only way that we can solve this question. This is the only way we can maneuver in order to get common denominators. If they have two totally different denominators like we have here, you just need to put the left one on the left, or sorry, the right one on the left and the left one on the right. Okay, this is very similar to if we had this question. We can't turn the 3 into a 5. We can't turn the 5 into a 3. We would need to put a 5 over here and put a 3 over here. Okay, it's the same thing that we've done right here. Okay, so again, very similar to old school 4th grade questions, just kind of like souped up, that's for sure. So now we've got common denominators, b and b plus 3. On the top, we've got b squared. Over here, again, it's getting a little tricky. We've got to sort out all this PEMDAS. I've got to make sure that I don't forget this minus sign. And I've got to handle the 4 times b plus 3. Okay, so what I would probably do for this question is write it out. Okay, minus 4 times b plus 3. Okay, because I'm not confident that I could distribute the 4 and distribute the negative without messing up or without forgetting something. So let's just write it out like this. b squared minus 4b plus 3. Kind of sounds like the quadratic formula almost. And now I'm going to need to go ahead and distribute this. You know, to make the same point I made on the last question, we cannot cancel these out because this subtraction sign has locked all of this together. So we cannot cancel those two things out. We need to distribute this. We're going to get, use a better color, b squared minus 4b minus 12 over b times b plus 3. That's a minus 4 and a minus 4. And now we've sorted out all the algebra. Now it's time to do the questions from Monday, right? Now it's time to simplify the rational. We need to look at the top and try to factor it. I'm looking at this and saying that's going to be a negative 12, opposite signs, 1 times 12, 2 times 6, 3 times 4. How can I make a negative 4? I'm going to need to use minus 6 plus 2. So I'm going to end up with b minus 6, b plus 2, all over b times b plus 3. I hate questions where they make me put b's and 6's right next to each other because my handwriting is not good enough. But all right, looking at this question, we did all this work, okay? We made sure that we distributed the minus correctly. We made sure that we factored it correctly. We took our time, and we got all the way down to here, and it's a little bit anticlimactic. Nothing is crossing out for us, okay? Now, if I got here, I might do a double check, okay? I might go back over here and say, yeah, that should have been negative 4b minus 12, negative 4b minus 12. Okay, that looks good. Double check the factoring, negative 12, opposite signs, minus 6 plus 2 makes negative 4. Okay, so we haven't made any mistakes. Nothing cancels out. That's okay. Totally a possibility. Sometimes everything will cross out. Sometimes nothing will cross out. As long as we followed the rules, done everything carefully, we should be good. Looking at the rest of these questions, sometimes you get, a little bit weird stuff, but you can see here how this is going to be a 4 and a p minus 5. If I just do this really quickly, a 4 and a p minus 5. This is going to be factored, and I'll do it for you, p minus 5, p minus 3. And so what do I see in the denominator? This is why I like the list, okay? I see a 4 in the denominator. I see a p minus 5 in the denominator. Oh, my God, I'm struggling with the circles today. And I see a p minus 3 in the denominator. And so I need both of my denominators to have all three of these parts. Over here, I need the p minus 3. Over here, it looks like I got both the big parts, but I'm missing the 4. So I've got to multiply by 4. Take this and multiply by 4. Okay? So when you're doing this, I like the list. It's kind of, undervalued by some students, but I think this can really help out. It's factor the bottom, make sure your bottoms are the same, and then adding the tops is very Algebra 1, and then the rest of it is just stuff we've already learned yesterday. So it's definitely a tricky day. In my mind, it's one of the hardest days of Algebra 2. So if you're working hard, if you're feeling decently after these notes, that's really good news. Watch this video again. Look through some of the questions, find a worksheet with keys, and work carefully, write neatly. That's kind of your biggest help here. Again, we've got this strategy for unlike denominators. Factor the denominators, then get the common denominators using multiplying. PEMDAS the numerator, use Algebra 1, and then simplify. All right, that's it for adding and subtracting rationals. Hope this helped. See you guys.